So we've got a number here, and we want to express it as a ratio of integers. So the way we do that is by turning this into a geometric series. You're always going to have a geometric series with these sorts of things when you have a bar over some of these decimal values, because all you're doing is really shifting it. You know, you have like 3 spaces here, and then you have 3 spaces again, 3 spaces more, and then 3 spaces more. That's telling you, hey, you're just taking something to an exponent. So what is going to be our knowing that, what is going to be our common ratio in our case? Well, it's certainly not going to be 0.234567, because the 0.234 is not part of the bar thing. It's not going to be part of the repeating thing. And let's remind ourselves what that actually is. So this would be the same as 1.234, and then we have 567, and then to this we would be adding 0.000000567. Why 6 zeros? Because we have like 6 here, right? We've got 6, we've got 3 spaces here, and we're just going to be adding 3 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to have, did I count 1, 2, 3, 4, whatever. The point is 9. So you're always going to be adding 3 zeros more. If we're adding 3 zeros more, because we have 3 here, we have 3 spaces, this takes up 6. So we're always adding 3 spaces more. In other words, 3 decimal places. We've got 0.001, and that's what we're taking to our exponent. We tend to initialize series at I equals 1, or n equals 1, whatever variable you're using. So in that case, we make this n minus 1. Whenever we start this at 1, we put a minus 1 over there so that we can easily have a value here. So that we can easily have a value here and have this go to 1. Because if you plug in 1 into here, the exponent is 0, this goes to 1. So we want the repeating sort of kernel of value to be that. So this is 0.567. Is going to be our, actually, no, that's wrong, because this is not our first value. It would be 0.000567. That would be what we would want to be our first value if this goes to 1. And of course, this other thing is just added, and that's just added because it has nothing to do with the geometric series. It's not repeating or anything. That's just added to the thing. This is what's crazy, what's repeating over there. So remember, we had 3 spaces here, almost made a mistake and didn't even put the 3 spaces, because this starts at 3 spaces. It starts at 3 spaces after from the decimal place, from the decimal point. So, and then we move 3 other places again. You know, we're going to go 1, 2, 3, 1, 2, 3, and so on. So that's why we have 0.001 in there. 3 decimal places for each time, and each time is represented by the increasing exponent. Okay, so now that we have that, we can move on to the next step, which is to solve for this. We know it converges because our common ratio is less than 1, obviously. This is our common ratio, and it's less than 1. So now we just remember the formula, which is a over 1 minus r. A in this case would be, in any case, is when you plug in your first term. So you plug in your first term here into there, and whatever you get left here in this in the sequence, in just the sequence itself, which is here, that's what A is. So in our case, that would be 0.000567. R is 0.001. And when you solve for that with your calculator, you get this. So the important thing is really that work over there. Once you get it into this form, you plug it into your formula. You don't really have to do it by hand if you don't want to.